Okay guys, we're going to do lesson 11.2, which is on the area of trapezoids, rhombi, that's just plural for rhombus, and kites. So we want to find the area of trapezoids and we want to be able to find the area of rhombi and kites. A trapezoid is a quadrilateral with exactly one pair of parallel sides. And those parallel sides are the bases. So if I have the non-parallel sides, they can never be the base. They have to be the parallel ones. The height is always the perpendicular distance between those two bases. And you can see that we have a picture there in the lower left corner or lower right corner there with our two parallel bases and our height. So we can mark the height inside or we can mark the height outside. To find the area of a trapezoid, you're going to take 1/2. It says h times b1 plus b2. I've always remembered it as area equals 1/2 base 1 plus base 2 times the height, because a trapezoid makes me think of a triangle with the top cut off, and the area of a triangle is 1/2 base times height. The difference is instead of having one base, we have two for a trapezoid. But you can see we have a base 1, we have base 2, and there's our height for that. And that's how we find the area of a trapezoid. So we're going to try this out. We have a little picture here and it says one of Brianna's trapezoid shaped totes is shown. Find the amount of material used to make the side shown. So, you know, it's just a picture of a purse, but you know, it's really a trapezoid, so don't get too panicked by it. I'm just going to outline that trapezoid, and then we have a height here. Okay, so the part shown, this is base 1, which is 28 centimeters. Base 2 is the 58 centimeter side, and the height is 30 centimeters. So you want to fill out your equation. I always do that first, is to just write your equation down without any values in it. So this says area of a trapezoid is 1/2 base 1 plus base 2 times the height. And I'm just going to substitute the parts that I have to find the area. So we said that base 1, we're going to let that be the 28 centimeters. It really doesn't matter which one's base 1 and base 2. They're completely interchangeable. But I just always go top to bottom. So 28 centimeters is going to be base 1. Base 2 is 58 centimeters. And the height is 30 centimeters. Then you have to follow the order of operations. So I'm going to add 28 centimeters and 58 centimeters first, which is going to give me 86 centimeters. And then I take that times the height, which is 30 centimeters. And that leaves me with an area of 1,290 centimeters squared. So that's the area of the trapezoid, which that's the same amount of material then that I would need to make that bag. A rhombus is a parallelogram with 4 congruent sides, and we've got a picture of that below. And a kite is a quadrilateral with 2 pair of consecutive congruent sides. So consecutive just means one right next to the other. And we have a picture of what a kite would look like. For both of these, we can use the same formula because both of those the areas are directly related to the lengths of the diagonals. And so our formula for both a kite and a rhombus, so this is my rhombus here, and this is my kite, is the area is 1/2 diagonal 1 times diagonal 2. And again, it doesn't matter which one you consider diagonal 1 or diagonal 2, just that there are 2 diagonals in those figures. The diagonals are always drawn from a vertex to the vertex on the opposite side of the figure. Example 3, find the area of each rhombus or kite. So in this figure, we actually have a kite, and it's telling us that the length of this diagonal is 8 meters, and the length of the vertical diagonal is 15 meters. So I'm just going to mark that in my picture that we'll make 8 meters diagonal 1 and 15 meters diagonal 2. And then I want to write down my equation using the diagonals for the area of my kite. I make a little kite picture. Is 1/2 diagonal 1 times diagonal 2. And we're just going to substitute. So 1/2, we said diagonal 1, we're going to let that one be the 8 meters. Diagonal 2 is 15 meters. And then you can multiply that out. And you should get 60 meters squared. And that's the area of our kite. Problem B is a rhombus, it looks like. And for this one, they show us that the diagonals are bisecting each other there, and they don't give us the complete diagonal. They only give us half of that. So I have 12, and then the other portion of that diagonal is also 12. And so I'll call that diagonal 1. And diagonal 2 then we're given half of it is 10, so the other half is also 10 feet. So that tells me that, again, I'm going to let that be diagonal 1. Diagonal 1 is 12 plus 12, which is 24 feet. And diagonal 2, I'll make this one 2, is 10 plus 10, which is 20 feet. So there are the lengths of my diagonals. So I had to do a little bit of work before we could get started. Again, the area of a rhombus is 1/2 diagonal 1 times diagonal 2. So I'm going to take 1/2 times 24 feet times diagonal 2, which is 20 feet. And that result should be 240 feet squared. So the area of my rhombus is 240 feet squared. Okay, we're going to do a little bit of an application problem where we're actually missing some measurements. It says one diagonal of a rhombus is twice as long as the other diagonal. And so I've gone ahead and given you a picture of what that would look like. If the area of the rhombus is 169 square millimeters, so we know that area is equal to 169 millimeters squared. What are the lengths of the diagonals? So what uses area and what uses the diagonal is our equation for the area of a rhombus, which is 1/2 diagonal 1 times diagonal 2. So I have my two diagonals and it gives me my length in terms of expression. So I'm going to make the diagonal that has length x diagonal 1 and the one that has length 2x is diagonal 2. And then I can fill in the parts that I know. I know that the area is 169. Diagonal 1 we said was x. Diagonal 2 is 2x. And then you can simplify. Normally I would get rid of the 1/2 by multiplying on both sides, and you can certainly do that, but I also see that I have half of 2 on the left side because I have 1/2 times 2, which is going to just leave me with 1. So I could go ahead and simplify that and get 169 equals x times x, or x squared, which tells me that x is actually 13. So I can substitute in for my diagonals. If diagonal 1 is equal to x and x is 13, then diagonal 1 is 13 millimeters. And diagonal 2 is 2x. So when I substitute, I get 2 times 13, which is 26 millimeters. So there are my two diagonals, 13 millimeters and 26 millimeters. On 4B, We're still finding a missing value, but this time we don't have a rhombus or a kite. We are back with a trapezoid again. And I'm given the area of the trapezoid. And I'm given lengths to the two bases. So I'll make actually this base 1 and 11. X is going to be the base 1. 11 is going to be base 2. And the height is 13. So what uses all of those parts? The formula for the area of a trapezoid, which is 1/2 base 1 plus base 2 times the height. Again, fill in the parts that you do know. I know the area is 177. I have the 1/2. Base 1 we let be x. Base 2 we let be 11. And the height is 13. Now in this case, I have the 1/2, and I don't have anything that's going to reduce with the 1/2 on the right side of the equation. So I'm going to actually multiply that on both sides. And so multiply by 2 on the right and multiply by 2 on the left. And take that product. 2 times 177 is 354. My 1/2s are now gone. And that leaves me with x plus 11 times 13. It doesn't matter that our monomial, our 13, is on the right side. We're still going to distribute that. So 354 equals 13x plus, and then 13 times 11 is 143. And now we've got an equation where we can solve for x. I'm going to subtract 143 from both sides. And so that leaves me with 211 equals 13x, and then you divide by 13. And I get x equals 16.2 centimeters. So that was equivalent to base 1 there. You have an assignment. You're going to do page 793, numbers 5 through 13, all of those. Okay, and I will see you on Friday. Have a good day.